Hyperparameter Tuning using randomized search. Hello everyone and welcome to this tutorial. Till now we have completed these two important steps that are pre-processing and the model building. In model building, we have tried three different machine learning models: multiple linear regression, random forest regression, and XGBoost regression. And after that, based on the R-square score, we have finalized a random forest regression. Now, in this tutorial, we have to do hyperparameter tuning. Let's begin. Open sklearn documentation and then go to API. And here we have to look for model underscore selection. Scroll down. This is the model selection. And here this one, randomized search CV, opens in a new tab for parameter tuning. We are going to use this class randomized search CV, and we have to import this class from sklearn.model underscore selection. To copy this from sklearn.model underscore selection, import randomized search SV and execute. Let's understand the main difference between grid search CV and randomized search CV. In randomized search CV, not all parameter values are tried out, whereas in grid search CV, all parameters are tried out. So, this is the main difference between randomized search and grid search CV. And because of this difference, not all parameter values are tried out in randomized search CV. It takes a little bit of time than the grid search CV, and that's why we are using randomized search CV. Now, go to Colab Notebook. Now, we have to tune the parameters. Go to Random Forest Official Documentation. This one, first parameter is an underscore estimator. So, copy this, define a variable parameters. This will be a dictionary. The first parameter is an underscore estimator. We will try different estimators: 200, 400, 600, 800, 1000, 1200, 1400, 1600, 1800 and 2000. So these are all n underscore estimator values that we are going to try. Let's move forward to the next parameter. After n underscore estimators, we will tune this parameter max underscore depth. Copy this. Specify values from 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 and then none. So, this is the maximum depth of the tree. Then scroll down. This parameter min underscore sample underscore split. Copy this in a single code and paste. We will try 3 values only: 2, 5, 10. So, this is the minimum number of samples required to split an internal node. The next parameter is min underscore sample underscore leaf. Here also we will try 3 different values: 1, 2, 4. Let's check for the next parameter, max underscore features, and copy. We will try these 2 values first. One is the auto and the second one is sqrt. So, this is the number of features to consider when looking for the best split. And then scroll down to look for bootstrap. Copy this and paste it here. There are only 2 values, true and false. Whether bootstrap samples are used when building trees, if false, the whole dataset is used to build each tree. Now, we are not going to tune all other parameters. We will tune only these 6 parameters and execute. Take this value parameters and now create an instance random underscore CV, and this is the instance of this class randomized search CV. First, we have to specify estimator is equal to regressor underscore RF, random forest. Then, parameter distributions. Parameters is the value that we have defined here. After that, number of iterations, I will specify 50, then CV is equal to 5 by default. CV is equal to none. Let's check what is CV. Here we can see in this official documentation, this is the cross-validation generator. By default, it is none. Then verbose is equal to 2. After that, n underscore jobs are equal to -1. Let's understand this n underscore jobs. By default, it is none, and then n underscore jobs are equal to -1, which means we are using all the processors and at the end specify. The random state is equal to 0 and execute. Great! Now we have to train the model random underscore CV dot fit x underscore train y underscore train and execute. So, the model training is started here. So, we will take a little bit of time to build. So, here we have successfully trained our model. Now to scroll down. Type random underscore CV dot best underscore estimator underscore and execute. So, these are the best estimators. Type random underscore CV dot best underscore parameters. So, these are the best parameters. Bootstrap is false. Maximum depth is 50. You can see here there are multiple values of maximum depth from 10 to 100, and none out of this 11 values, the best value is 50. Max underscore features are SQRT. MIN underscore samples underscore leaf is 1. MIN underscore samples underscore split is 2. N underscore estimators is 1200. So these are the best parameters. Now add one more section. The final model random forest regressor. Now copy this model and paste it here. Now we will call only the regressor, and here we have to specify the best parameters. Copy all this from the best estimator and paste it here and train the model. So here we have successfully trained our final model with the help of this best parameters. Now check the accuracy. To do that, redefine y underscore pred is equal to a regressor dot predict x underscore test method, and at the end calculate R square score. So the R square score is 0.8425, and previously it was around 0.8435. Now it is in a similar range. Now go to random forest regressor. So this value keeps changing. It is between 81 to 83. Now it is around 84, and this because I rerun all the cells multiple times. So this is how we can tune the parameters and finalize our model. To tune the parameters, you can try multiple combinations as well, as you can tune other parameters that we haven't used here. So this is all about the house price predictions. Let's revise what we have done in this project. First, we have done the pre-processing. Here we have imported the libraries and the data set. After that, we have done the data exploration. Then we have dealt with null values. After that, we have drawn disk plot, then correlation matrix. After that, we have dealt with categorical values. Then we have split the data set into training and test set. At the end, we have applied feature scaling. Next, we have 3 different regression models that are multiple linear regression, a random forest, and XGBoost. On the basis of performance, we have finalized random forest. After that, we have tuned the parameters, and this is our final model, random forest regressor. Oh, so this is all about this project. I will see you in the next tutorial. Till then, happy learning.